Hello fellows, welcome to the December strategy for science. And today, kind of mirroring what the math content strategy focuses on, is using movement throughout the classroom to engage students in learning. Now I want to kind of play a game of almost two truths and a lie. And the lie being that there is empirical evidence for specific learning types. We often hear people say, oh, I'm an oral learner, or a visual learner, or a kinesthetic learner, so I need to learn things in this way. There actually is no research evidence that individuals are particular types of learning. It is true, however, that people have preferences and often feel engaged, more engaged in significant ways through different types or forms of input. So there are preferences we have. But the other thing that is true is that we learn through many different inputs over the course of our lives and through many different media and through many different ways. And so it's our job to create opportunities where we do vary instruction so that everyone is exposed to oral, visual, and kinesthetic opportunities for learning. This just builds their own capacity for learning in different contexts and environments. So today we're going to focus a bit on this kind of kinesthetic part. How do we get students to deal with ideas while also moving around? So I want to go back, we're going to show three brief strategies. The first is going back to the summer when we talked about the snowball fight and peer instruction and getting kids ideas on the table while moving around. So we're going to talk about the snowball fight and then two other Kagan-based strategies. Kagan is a corporation that focuses on educational consulting, and they have some nice structures that teachers can use for organizing movement in a very structured way around the classroom. So if you remember, or if you don't, the snowball fight is just an opportunity for kids' ideas to get out on the table in an anonymous way, so they can be very safe in talking about their misconceptions, but over time move as a class toward the proper idea. So through several of these structures today, we're going to use this question that often has a lot of misconceptions about what causes the seasons. So let's say you start with a really good conceptual question that there might be a lot of different perspectives on it. You give students a question, maybe you give a handout, or more likely you post it on the board, that asks the question, and then it has to have 3 to 5, 4 is a good number, right in the middle, possibilities for answers. So it is multiple choice. So you give, one of them is the right answer, but then others are likely misconceptions that you have heard from students previously. Students all answer on their own individual sheet of paper, whatever letter they agree with. Then they crumple it up and they love this part, and it's a snowball fight. And you have to manage this and know your students, so you can either have them all throw it into the middle of the classroom, or I like going around with like a small garbage can or a box where they can throw their wads of paper into the box. They do not put their name on it. The point is that they can be safe in responding and seeing how others respond and try and form their ideas and shape their ideas over time. So once you have everyone's idea in, each student goes and picks, I hope you like my artwork, an individual snowball that's not their own. They open it, and then they make a human histogram. So we're actually using the people mathematically. So they represent 2 people had answers that supported the answer with A, 3 people with B, 1 with C, and it looks like 5 with D. At this point, as the teacher, I can stop and say, okay, let's look at the distribution. Not everybody thinks the same, so there's obviously a lot of different ideas on the table. This is good for you in terms of your own formative assessment to see what ideas are out there. But now you can have students pair up with either someone from a different group, if there are enough, or even from their own group to justify which answer they think is correct and why. That's the most important key. How do we get kids to explain why they think it's correct? After you do this, you can have them turn over the sheet that they have, kind of cross out the answer from the first side, write their new response, regardless, I should say, of which group they were in. They write that response on the back, crumple it up, put it back in the basket, and do the human histogram again. You'll almost always see a distribution shift toward the correct answer. And you haven't said anything as the teacher yet. This is all getting students' ideas out there, but they're moving around the classroom. They're physically seeing the distribution of ideas and thinking why those ideas may or may not be canonically correct. So now we're going to move on to two other strategies for using structured group work and movement about the classroom to get ideas on the table. All right, so we talked about the rationale for engaging students in multiple ways of learning, and that could be oral, visual, or kinesthetic. And especially at this time of year when we want students to get those jitters out as the holidays come up, here are a couple strategies you might use to have students use their ideas, engage the ideas of fellow students in meaningful and structured ways. So this first strategy is called stand up, hand up, pair up. It's really a modified pair share that has a lot of structure to it. The first thing you'll do is ask a nice conceptual idea or question for which students might have many ideas. So you want to get as many ideas on the table as possible. After that, when you say go, all the students will stand up, they'll put their hands up, and they'll find someone else with their hand up. They'll give them a high five, then the first person will say their idea about the science question. The second person will then share, and when they're finished, they'll both put their hands up, searching for another partner. You have a designated amount of time, say 3 to 5 minutes, that would allow students to engage the ideas of about half the class or so. So we have a great, I thank my colleagues here, a great classroom that will demonstrate this technique. So this is stand up, hand up, pair up. All right, class, we're going to do stand up, hand up, pair up, and you know the structure. Yep, Garrett loves this one. And we're starting to talk about the solar system and the seasons. So the question on the table that I want you to think about is, what causes the seasons? All right, so we're going to go for 3 minutes. And does anyone have any questions? Great. All right, stand up, hand up, pair up. Go to it.
So I think it's because of the axis of the Earth and how far the Earth is from the sun at any given time of the year.
Interesting.
Okay.
Hey.
What's your idea?
I think it's the orbit of the Earth around the sun.
It's like every day's a season. Kind of like
What about you?
everything.
I think it's...
All right, and time's up. So, as you can see, they're engaging the ideas. They know exactly what to do. So structure and modeling this for the students is important. Now, one thing to point out is that not every pair, what I really like about this is not every pair has to be done at the same time. Some may take longer to share their ideas, at which point they keep going while others have their hands up. So it just might take a few seconds or a minute for other hands to show up. And if they're across the room, that's fine. They can get to them because they see their hand up across the room. So that's stand up, hand up, pair up. All right, so the second strategy that we're going to use comes from Kagan as well. So we're crediting Kagan structures, focusing on organizing talk around the classroom. And this one is called Quiz Trade. What's nice about the Kagan structures is the name actually tells you exactly what you need to do along the way. So in Quiz Trade, there are multiple ways of getting the content ready. I would suggest that you start with the teacher creating note cards, so it takes a little bit of time, with ideas from the science class. This might be declarative knowledge, it might be conceptual questions, but you write each on a card, and on the back or at the bottom, you write answers or potential answers. Once kids get the structure down, you might put it on them as an exit card at the end of the day to write their own question. That way, when they come back, they've contributed to the discussion, and it's been an educative experience for them in creating those questions, like a metacognitive principle. But once you have the cards ready, every kid, every student in your class gets a card with a question. When the teacher gives the instructions, everyone again stands up, they put their hands up, and they find someone who also has their hands up. and then they quiz. So I'll ask my partner my question, and here's the key. We want them to become experts on that question. So we don't tell them we don't tell them the answer, but if they're not right, we say, no, try again. If they're not right again, we might provide a hint and do a little coaching, at which point they should become comfortable with the content. Then the second partner asks the question, and we do that cycle over again. And at the end, we trade cards. So now I'm seeing different content throughout the whole activity. You put your hands up, find someone else with their hands up, and you continue with the pattern for the allotted amount of time. So again, I thank this wonderful group here. They're going to show you quiz, quiz, trade. So class, you each have your cards that you created these questions yesterday and thought through the answers. I looked them all over, and all of them looked like really good questions and acceptable answers on the card. So we're going to do quiz, quiz, trade. Just a reminder, you'll stand up, put your hands up, find a partner, and begin quizzing. Don't tell them the answer unless it's on a second or third try, where you might do a little coaching for them to get the answer. Then you'll switch cards and find a new partner whenever you're finished. All right? Go to it.
All right.
Okay.
If a bag
Yes.
is being pulled
If a
in two
puck is
opposite
pushed
directions,
across the
but
ice
one
rink,
force
but
is
no
larger than
friction,
the
would
other,
it speed
what will happen
increase,
to the bag?
decrease, or stay the same?
That's a great
And
answer.
run off.
Did a good job.
Yeah.
We can switch,
It's a
right?
pretty good explanation there. Yeah, is there anything else you want to add to
I
that?
think that's it.
Okay, I think you got it. Good job. Okay.
Oh.
Try again. All right. That's
Um,
your question.
You want to ask me?
What?
So these are just 3 ways, the snowball that we showed earlier, and then the 2 Kagan structures, that you can engage students in content in a very organized and structured way, while also getting them to move around the classroom. So I thank my colleagues for helping out today, and let's have some great science learning.